Hi all, in this video I am going to explain about stack based CPU organization. Normally in a digital computer, the stack can be implemented in two different ways. Either we can implement as register stack or we can implement as memory stack. So in this video I am going to explain about memory stack. So before going to this memory stack, we have to get an idea about stack organization or what is stack. A stack is a data arrangement structure in which the data is stored in such a manner that the last item which is added in the stack is the first item to be removed. That is, from this diagram we can clearly understood that the books or the racks which are arranged one by one and the items are arranged in a manner that the last item added is on the top and the first item which is removed is from the top. So we can say that stack is based on the principle LIFO manner. LIFO means last in, first out. That is, the last item which is added into the stack is the first item to be removed. So the computers which use the stack based CPU organization are based on the data structure called stack. So the every operations is performed on the stack data, and stack is a storage device that stores the information in such a manner that the last item which is added onto the stack is the first item to be removed. And we can say that the stack uses the access method LIFO. LIFO stands for last in, first out. Normally in a digital computer, the stack can be implemented in two different ways. The first one is a register stack and the second one is memory stack. Now we are moving on to this memory stack. So in memory stack, the memory of the computer system, that is the random access memory, can be arranged in the form of stack. So a stack can be implemented in a random access memory attached to the CPU. That is, the implementation of the stack in the CPU is done by assigning a portion of the memory to a stack. That is, in memory stack, what is actually happening is the memory of the computer system or the memory of the system has been divided into three major areas. That is, one part is scheduled for the stack and the other part is scheduled for the data and the third part is scheduled for the program. So here in this computer, the memory is partitioned into three segments. The first one is the program. Program means the instructions. That is, one area of the memory is allocated for the instructions. And the another area of the memory is allocated for the data, or we can say that the operands. And the another part is allocated for the stack. In this way, the memory can be arranged in the form of stack. So there are certain registers which are associated with this memory stack. That includes, the first one is the program counter. Program counter stands for PC. PC actually points at the address of the next instruction in the program. So at a point of time, whatever instruction the CPU is executing, at that time it has to ensure that the next instruction to be executed. For that purpose, the program counter is using. So the program counter actually holds the address of the next instruction to be executed. Address register AR points at an array of data. That means it contains a series of memory locations. So through that memory locations, we can directly access the data. Stack pointer. Stack pointer is very important or essential in the stack organized system, because the stack pointer points to the address of the topmost element in the stack. That is, in the stack, as I mentioned earlier, the items are arranged in the LIFO manner. That is, one by one, and the last item which is added is on the first item to be removed. So the first or the topmost element is very essential. So this register, stack pointer, is very important in a stack organized system. And these registers, that is the program counter, address register and the stack pointer, are connected to a common bus, that is the address bus, and either one can provide an address for the memory. And the last one is the data register. The data register actually holds the data. That is, whatever data we have to add into the stack or whatever data we are removing from the stack, that is stored in the data register. So these are the common registers which are associated with memory stack. So here is the diagram. It actually explains the memory stack. So in this, clearly we can understood that the memory is divided into three portions. One is the program, that is for the instructions, and the other part is the data, and the third part is for the stack. So we have the four registers are there: PC, program counter, AR stands for address register, and SP stands for stack pointer, and we have data register DR. So the program counter actually holds the address of the next instruction to be executed. Address register actually points to the array of data. Stack pointer holds the address of the topmost element in the stack, and the data register holds the data which is added into the stack or which is removed from the stack. And in the stack, we can see that the stack is arranged in the decreasing order. That is, its address starts from 4001, then 4000, and then 3999, 998 in this manner. That is, the stack is arranged in such a manner that is decreasing. The memory address is arranged in the decreasing order. So it's very important to add an item into the stack or removing an item from the stack. So whatever operations we have performed in the register stack, so here in memory stack it is entirely different from that. So in the figure, the initial value of the stack pointer is 4001 and the stack grows with decreasing address. Thus the first item stored in the stack is at the address 4000, and the second item is stored at the address 3999, and the last address that can be used for the stack is 3000. So it is clearly understood that the stack is arranged or the memory address is arranged in the decreasing order. Now we are moving on to the various operations performed in the memory stack. So there are basically two operations which are normally performed in the stack. That is, one is the push operation. So push operation means the adding or the inserting a new data item into the stack. That operation is known as push operation. And for adding a new item into the stack, we have to check whether certain conditions. That is, we have to check the stack is full or not. And if the stack is not full, we have to perform certain set of activities. The first thing we have to do is decrement the stack pointer, because the stack pointer actually points the topmost element in the stack. So the address is arranged in the decreasing order. So the first thing we have to do is the stack pointer has to be decremented. Then only it moves to the top of it reaches the top of the stack. After decrementing the stack pointer, we can take the data which is stored in the data register to the stack pointer. So we can write like this: SP gives SP minus 1 and the data register is transferred to the memory address of the stack pointer. In this way, we can perform addition into the stack. Next is the pop operation in memory stack. So pop operation means removing or retrieving an element from the stack. So we have to remove an element from the stack. We have to check certain conditions. That is, the first thing we have to do is we have to check whether the stack is empty or not. If the stack is empty, we cannot remove an item from the stack. So the first thing we have to do is checking the stack is empty or not. If the stack is not empty, then we can ensure that we can remove an item from the stack. So for that purpose, the first step is the content of the stack pointer is moved to the data register. That is, the stack pointer actually points to the topmost element of the stack. So that data is the first item to be removed. So whatever data is stored in this particular location, that data has to be shifted to the data register. And after that, the stack pointer has to move to the next location. So the stack pointer has to be incremented, because in this memory stack, the addresses are arranged in the decreasing order. So after the content has to be shifted to the data register, the stack pointer will be incremented. And we can write like this: the content of the stack pointer has to be shifted to data register and the stack pointer value will be incremented by 1. That is, SP gives SP plus 1. In this way, we can perform the pop operation. That is, we can easily remove an element from the stack. In this video, I explained about memory stack and the various operations performed in the memory stack. Thank you.